Okay, so this section is on partial fractions. And what we're going to be able to do is integrate a rational function using the method of partial fractions. And we're going to have some that have simple linear factors, some that have repeated linear factors, and then some that have quadratic factors or irreducible factors. Okay, so let's start off with the fact that we have an integral of a rational function. That is, it's the integral of one polynomial p of x over another polynomial q of x. And our goal is to write it as a simple polynomial p of x with repeated fractional parts. And those repeated fractional parts are like f1, f2, all the way up to however number there are. Okay, so there are two cases. The first case is when the power of the numerator is greater than or equal to the power of the denominator. And in this case, we're going to use long division. So you guys remember long division. I always did it. Does Mary sell balloons? Divide, multiply, subtract, bring down. Whatever works for you, that's what we're going to do. All right, so first problem is simple division problem. So we're going to divide x cubed plus x into x cubed. We have to make sure we have a placement holder for the x squared, a placement holder for the x, and then minus 1. Okay, so any term that are not there, make sure you have placement holders. Okay, so x cubed goes into x one time. So 1 times x cubed is x cubed. All right, and then we have to multiply the 1 times the x. So that's going to give us an x here. Then we will subtract. So x cubed minus x cubed gives us nothing. 0 minus x is going to give us a negative x, and then we're going to bring down the negative 1. And at this point, the power of the integrand is too small. We can't divide x cubed into x, so we're done. So this becomes our remainder. So this is our remainder. Something is not right.
Is the x squared supposed to be coming down?
Well, it's a 0, so I didn't bother.
Okay.
If it had been something there, I would have definitely brought it down. That would have been the next term to bring down, yes. Okay, and you'll see that in the next one that I do. Okay, so now we get that x cubed plus x over, nope, that's wrong. X cubed minus 1. Over x cubed plus x is equal to 1 minus x minus 1 over minus x over x cubed plus x. All right. So let's separate this into 1 minus x over x cubed plus x minus 1 over x cubed plus x. Okay. So now this middle term simplifies to -1 over x squared plus 1. So now I get, if I want to do this, the integral of x cubed minus 1 divided by x cubed plus x dx is the same as integrating 1 minus 1 over.
What you talking about that? I feel like it matters with people who got like different, like, how I say this? I think it depends on they little nose. You feel me? Like, I want to get that because I just, yeah.
Over minus 1 over x squared plus 1. That part we can integrate. Minus, we still have this integral of 1 over x cubed plus x. Okay. So this now gives us, this part is just x minus, what's the integral of 1 over x squared plus 1? What is the integral of 1?
Tangent inverse.
Tan inverse, good. Plus, minus this one integral that we haven't figured out how to do yet, because we haven't been taught how to do it. And this little last remaining integral here is we would do this using partial fractions, which is what we are going to learn today. Although we will not learn how to complete, I don't think we're going to get to actually completing that integral today. Okay, so if the powers are the same or the power of the numerator is greater, you use long division. So we're going to do another one like that. Nope, that's not it. Okay, second integral. Okay, so again, notice the power of the numerator is greater than the power of the denominator. So I'm going to do long division. So I'm going to have x squared plus 2x plus 2, and that has to go into x cubed plus x squared plus x minus 1. All righty. So x squared goes into x cubed x times. So x times x squared is x cubed. X times 2x is 2x squared. X times 2 is 2x. So I'm going to now subtract. So when I subtract, x cubed gives me nothing. I'm going to get a negative x squared. I'm going to get a negative x. And then I'll bring down the -1. Okay, so x squared goes into negative x squared minus 1 time. So -1 times x squared is negative x squared. -1 times 2x is negative 2x. -1 times 2 is negative 2. And then I'm going to bring down, oh, I got to subtract first before I bring down. Gotta subtract. Oh, nope, there's nothing to bring down. I'm done. What am I talking about? There's nothing else to bring down. I just subtract. So therefore, I'm going to get nothing here. I'm going to get a positive X here and a positive 1 here. Okay, so again, this is the remainder. Okay, so when I go to write this, I have x squared, sorry, x cubed plus x squared plus x minus 1 divided by x squared plus 2x plus 2. Well, that's going to equal x minus 1. And then I'm going to get plus x plus 1. This is the remainder over x squared plus 2x plus 2. So now I found out what the integrand actually is. Okay, so now what I want to do is I want to integrate it. Okay. So the integral of this thing, I need a dx. Is the integral of this whole piece. So now the first piece is easy. So that's the integral. The first piece integrates to x, 1/2 x squared. The second piece integrates to x. And then I have the third piece, which is the integral of x plus 1. And that is over x squared plus 2x plus 2 dx. So we need to integrate this last piece. We had to figure that out. So that's not actually difficult. Let's let u equal x squared plus 2x plus 2. And du is going to be 2x plus 2 dx. And I'm going to factor out the 2 and get x plus 1 dx. And I can say, wow, look at that. Here's x plus 1 dx. And here is x plus 1 dx. So x plus 1 dx is equal to 1/2 du.
So everything becomes 1/2, Dr. La,
Where do
on the
you mean?
numerator?
What do you mean everything?
On the numerator, on the x plus 1 dx.
Yeah, the whole thing is going to be 1/2 du.
All right, thank you.
So therefore we have the integral of x plus 1 divided by x squared plus 2x plus 2 dx is equal to the integral. The whole top is 1/2 du, and the denominator is just u. Wow, okay. This is 1/2 the integral of du over u, and we know that that is 1/2 of what? 1/2 of what?
Natural log of u.
Good. So therefore this integral becomes 1/2 the natural log of the absolute value of x squared plus 2x plus 2 plus a constant. So now I can finish my original problem. So my original problem was integrating this thing. So integrating x cubed plus x squared plus x minus 1 over x squared plus 2x plus 2 dx. We already got the 1/2 x squared. And we already got the negative x. So now I need to add to it 1/2 the log of the absolute value of x squared plus 2x plus 2 plus a constant. Okay, so we have now solved our second problem. All right. So neither one of those problems I could solve using partial fractions in the beginning because the power of the numerator was greater than or equal to the power of the denominator. So now when we look at that case, so this is the case where the power of the numerator is less than the power of the denominator. We can now look for linear partial fractions. All right. Actually, I want that to be factors. Okay. Okay, so here's the technique. And we're going to go over this several times. So the technique we're going to use, the first thing we're going to do is split the rational function using factors of the denominator. What does that mean? That doesn't even make sense yet. Okay, we'll figure it out. Find the roots of the denominator, find the major equation, use the roots to solve the major equation for any variables we created, choose additional values if necessary, and substitute and integrate. Okay, so let's start with some examples, because examples for this section are the best way to go. Okay, so here's example number 1. And it is the integral of 4 over x plus 2 times x minus 3. And so it says split the rational function using factors of the denominator. Okay, so our denominator factors are x plus 2 and x minus 3. So I'm going to actually take 4 over x plus 2 times x minus 3, and I'm going to split it into a over x plus 2 plus b over x minus 3. Okay, so that was step 1. So step one says split what we have into rational functions. Split the rational function using factors of the denominator. So we split it. So notice how it was split into a over x plus 2 to b plus b over x minus 3. Second step, find the roots of the denominator. So that's easy. Step 2. What are the roots of the denominator? X equal what?
X equals square root of 2.
Oh, you're making it way too hard.
Is it -2 and 3?
Yeah, just -2 and 3. Okay, Ezekiel, why were you trying to figure out why you were making it so hard?
Oh, I'm sorry. Yeah, I was looking at the wrong thing.
Okay, all right, no problem. Okay, so now that we have the roots, step 3 says find the major equation. Okay, so in order to find the major equation, we're going to need the least common denominator. So the least common denominator, well, that's just x plus 2 times x minus 3. So we're going to take the left-hand side, which is going to take x plus 2 times x minus 3, and we're going to multiply it by 4 over x plus 2 times x minus 3. And we're going to set that equal to x plus 2 times x minus 3. And then we're going to multiply it by the right-hand side, which is a over x plus 2 plus b over x minus 3. Okay, so now we simplify. So on the left-hand side, x plus 2, x plus 2, x minus 3, x minus 3, they divide out. So they just give me the numerator. So on the left-hand side, I'm just going to get the numerator. On the right-hand side, I'm going to take x plus 2, x minus 3, and I have to do the distributive property. Okay, so I'm going to multiply this by the first term a over x plus 2. And when I do that, the x plus 2's are going to divide out and leave a times x plus 3. Then I have to multiply x plus 2, x minus 3 times b over x minus 3. Something's wrong. So the x minus 3's are going to divide out, and I'm going to get b times x plus 2. All right, so that is the major equation. Okay, so that's the major equation. And once you get to the major equation, I can now use the major equation to solve for the coefficient, solve for the constants that we created. So we created a and b, so I have to solve for a and b. Okay, so in step 4, I'm going to use my roots. So let's let x be the first root, -2. When I put -2 into the major equation, the left-hand side stays 4. I get A. I'm going to get -2 minus 3 plus B times -2 plus 2. Oh, how nice is that? That's 0. So now I'm just going to get 4 is equal to -5A. The B is gone, so I get A is -4/5. So I have solved for my first constant. Any questions? Okay. Now we're going to let X equal our other root, 3. And so on the left-hand side, the major equation stays 4. Now I'm going to get A times 3 minus 3. Oh, well, that's going to be 0. That's going to be nice. Plus B times 3 plus 2. Again, putting everything into the major equation. And so I'll get 4 is equal to 5B. So B is 4/5. And I solve for my second coefficient, well, my second constant. And that's it. I only had to solve for those two. Okay, we don't need step 6 in this problem, which says choose additional values for X if necessary. So I will put in here. And it's not necessary for this problem. So now we need to substitute and integrate. Okay. Step 6. Okay. So we said A was -4/5. And B is +4/5. Okay. So therefore, let's integrate. So my problem, here's my problem. Okay, so the integral of that is going to be the integral of -4/5 times 1/x plus 2 plus a +4/5 times 1/x plus 3 dx, because we just made a complete substitution. All righty. This is -4/5, the log of the absolute value of x plus 2, plus 4/5, the log of the absolute value of x plus 3, plus a constant. So my answer is -4/5 the natural log of the absolute value of x plus 2 plus 4/5 the natural log of the absolute value of x plus 3 plus a constant.
Dr. Luck, I have a question.
Yes.
On the, when we're integrating, wasn't it supposed to be 1 over x minus 3 or the positive?
Which one was it? It was -3.
Yeah,
No problem. Good catch. Okay. Yes, it was all the way through x minus 3. I think I got it now. Okay, awesome. Next problem. Now, this next problem is not given to you in factored form. So that means we got to do some work to it. So we're going to start off with 4x squared plus 1 divided by x cubed minus 5x squared minus 6x is 4x squared plus 1. Let's factor out an x. And that's going to give us x squared minus 5x minus 6. And I think this should be it. And we're going to divide out x plus 1 times x minus 6. Okay, any questions? Okay. So now we're going to take 4x squared plus 1 divided by x times x plus 1 times x minus 6 and split it. So I'm going to get a over x plus b over x plus 1 plus c over x minus 6. Okay. Any questions? All I did was split it. All right. Least common denominator. Oh, we got to find roots first. Zero, -1, and 6. Okay, we're good. All right, least common denominator. Well, that is x times x plus 1 times x minus 6. So now I'm going to take x times x plus 1 times x minus 6 and multiply it by 4x squared plus 1 divided by x times x plus 1 times x minus 6 equals x times x plus 1 times x minus 6 times a over x plus b over x plus 1 plus c over x minus 6. Okay, who wants to give me the major equation? All we gotta do is multiply that out. Who wants to give it to me? Oh my goodness. I don't have, y'all aren't fighting over this. Okay, well, how about y'all do this? I will take roll while you write out what the major equation is. Okay, did you find the major equation? Who wants to give me the major equation? Prentice, what's the major equation?
Writing out right now, but is it a or 4x squared plus 1 equals a times x plus 1 times x minus 6?
X plus 1 times x
6
minus 6. Okay, keep
plus
going.
plus b times x times x minus 6
Good.
plus c times, well, that's where I was just stopping at, but c times x plus 1.
Awesome. Thank you. Awesome. Okay, so that major equation right there, that's going to be the thing that's going to help you solve for A, B, and C. All right, so our roots were 0, 1, -1, and 6. So let's go. All right, so let x equal to 0. So put in x equals 0 and tell me which variable you solve for. Put in x equals 0. Tell me which variable you solve for. Devin,
Makes sense to be A.
Is it A?
you got A, and it turns out to be what?
Hold on. 1.
6, 0.
Wait, hold up. You got 1 times 6.
1 time.
Wait, -6.
Okay. So we have 1 is equal to A times 1 times -6 plus B times 0 times -6 plus C times 0 times 1. So we get 1 is equal to -6A. So A is -1 over 6. Thank you, Devin. Let x equal to -1. Tell me what variable you solve for. And if you can, tell me what the variable is. Jose. Jose, can you give me an answer? Rodney.
Yeah.
Okay,
I was
where
the one
did you
helping
get?
you with the last problem, but I'll do it again.
Say that again?
You thought that was the person that you called on, you thought that was done speaking, but that was actually me.
Well, I called
From
on, no, I called on Jose and
no,
I
I'm
didn't hear
talking
anything. So
I'm
that's when
talking
I
about
called on
Devin.
you.
I'm talking about Devin. You thought that was Devin speaking, but that was me.
I thought that was Prentice speaking, but that, oh, okay, that was you, Rodney.
Yeah. But
Thank
I
you,
could
Rodney. Okay,
but I could do this one.
okay.
Wait. Do one. Finish writing it out first.
What's, okay.
Yeah, we're solving for B.
Hmm.
We're solving for B, right?
Well, you don't know which one you're solving for until you put the number in.
Okay.
It's only one of them will work for you, so you don't know which one you're gonna get. What do you get on the left-hand side?
Um, 0, 4x squared plus 1.
Mm-hmm. And X is -1.
Okay, so it's gonna be -4 plus 1, which will give you
Okay,
-3.
oh, wait a minute, -1 squared.
Oh snap! It's gonna be +1. Sorry.
Okay, so it's gonna
So
be
it's gonna be 5.
good. Okay, on the left-hand side, you get 5. Good. Okay, on the right-hand side, you put in -1, right?
Yeah. So you would you plugged in -1. You would have -1 plus 1, which cancels out to be 0, and then -1 plus 6 is 5. So it would be
-1 minus 6 is,
oh shoot. I'm sorry, -7. I wrote it
okay,
wrong.
all right, plus B.
Um, which is going to be which will be 7.
Okay, you put in -1 for X, so you'll get -1, and then -1 again. So what will that give you? -1 minus 6.
-1 minus 6 is gonna be -7.
Okay. Plus C,
Let's see.
-1, and then you put in -1 and you get
0.
good. Okay, so now we end up with 5 is equal to, and what's the only thing that survives?
B, which is +7.
7B. So B is equal to what?
So the answer is going to be 5/7.
Okay. All right, so now we found B. All right, let's let X equal +6. All right, so on the left-hand side, we're going to get 4 times 36 plus 1 is going to be A times 7 times 0 plus B times 6 times 0 plus C times 6 times 7. Okay. This is 145 is equal to 42C. So C is 145 over 42. All right, so now we have all of them. Okay. All right. Let's go back to our original problem.
We don't simplify. Wait, no, never mind. You
Simplify
can't
what?
simplify. You can't simplify that. Never mind. I'm
I
sorry.
don't think you can.
Yeah, you can't.
Yeah, I tried 3, 4, and 5.
Yeah, you can't. 3 wouldn't work.
6 doesn't work, 7 doesn't work.
Yeah.
So yeah. So I think that was the best we could do. All right, so let's go back to here. Okay. I forget A. -1/6. B, 5/7. C, 145/42. Okay. So therefore, our original problem which was this, okay, so this is going to equal the integral of -1/6 times 1/x plus 5/7 times 1/x plus 1 plus 145/42 times 1/x minus 6 plus a constant. And so now we have an answer. And that is -1/6, the natural log of the absolute value of x, plus 5/7, the natural log of x plus 1, plus 145/42, the natural log of the absolute value of x minus 6, plus a constant. And we have solved yet another problem. Okay. Questions about that problem? So those are two problems that we solved with linear factors. Okay. The next type of problem, of course, everything can get a little bit more difficult. So the next type of problem is when we have repeated roots. Okay. Okay, so repeated roots, our first example is this one. All righty, this is number 3. And this particular problem has a repeated root. So let's see what we get. So let's start off with 3x plus 2 divided by x cubed minus 2x squared. So we get 3x plus 2. And we're going to factor out an x squared. And that's going to leave us an x minus 2. So this is fully factored. We can't do anything else. Okay. And notice x appears in the denominator 2 times. That's actually x times x. So when I write this out, 3x plus 2 divided by x cubed minus 2x squared, I have to do a over x, but because it's a repeated factor, I have to do b over x squared. And then, of course, I have the other linear factor, c over x minus 2. Okay, so this is the way I have to split it up into partial fractions. All right, so x appears in the denominator squared. And so therefore I have to do an ax and a b over x squared. If it appeared 3 times, I would have a over x plus b over x squared plus c over x cubed, and then of course d over x minus 2. Okay, what are my roots? Well, x equals 0 appears twice, and then 2. Okay, so x equals 0 appearing twice, that second 0 is not going to help me. So technically, I only have 2 roots, 0 and 2. But I have 3 variables to solve for. So this is going to present a little bit of a challenge. Not too difficult, but somewhat of a challenge. Okay, so let's find the major equation. So when I multiply the left-hand side by the least common denominator, that is x squared times x minus 2. All right. When I multiply it by that on the left, I'm only going to write it out this last time. I'm not going to do this anymore. Three x plus 2 divided by x squared times x minus 2 is equal to x squared x minus 2 times a over x plus b over x squared plus c over x minus 2. All right, who's going to give me the major equation? Nathaniel.
Yeah.
All right, can you help me get the major equation?
Yeah, I think so.
Okay, let's work on it.
Um, so wouldn't the first one be when x equals 0?
Oh, we have to get the equation first. I understand you're trying to plug it in. I want to get the equation that I have to use to do that first. So I have to simplify the terms that you see on the board.
Oh, so it would be the first equation. So x squared times x minus 2.
Okay, and then it cancels with what's in the denominator, right? You see it?
Yeah,
So then what does that just leave?
3x plus 2.
Good, okay. Then on the right-hand side, when you distribute, you gotta use the distributive property.
Yeah. So you a times x squared times x minus 2.
Okay, one of the x's cancels. So the x squared here over this x, that's going to cancel or divide out and give me only one x. So I'm just going to have x times x minus 2. Now what happens with the b term? So the b term, I'm going to get this over that.
Okay. So it's just x minus 2.
That's right. And then the c,
X squared.
just x squared. Thank you, Nathaniel.
So
That's the major equation. There it is. All right, so when x equals 0, what do you get?
oh, you're still talking to me?
Yep. Mm-hmm.
Oh, 2 on the left side.
All right, 2 on the left side. On the right-hand side,
The a is going to equal 0.
a times 0, so it's gone.
The b is going to be b negative 2,
Good.
and the c is going to be 0.
So it's gone. So we get 2. So what is b?
B is negative 1.
Awesome. Okay, let's keep going.
Oh, the other root is x equals 2.
Okay,
So it's gonna be 8 equals the a is gonna be 0.
good,
The b is also gonna be 0,
good.
and the c is gonna be c4.
Okay,
And then c4 equals 8. So c equals 2.
okay, awesome. Okay, now we're kind of stuck, right? We're out of roots. We can't go back and use 0 again. Okay, we're out of roots. So when you have a repeated factor, you're going to run out of roots. And this is where we scroll back to our technique and we see statement number 5. Choose additional values for x if necessary. Okay, so this is the case. We ran out of roots. So now I'm going to choose any value of x I want. Now, I'd like to choose a small x. That'll be nice. I'd like to choose a positive x, so I'm not working with a bunch of negative numbers. So I've already used 0, so I'm just going to choose x equals 1. Now somebody else can choose x equals -1. You can choose x equals 3. You can choose x equals 11. it doesn't matter, the problem's going to work. I try to choose something small. So when I choose x equals 1, on the left-hand side, I get 5 is equal to a times 1 times -1 plus b. I already know b is -1. I'm going to put 5 in there. So no, I'm not. I'm going to put 1 in there. So I get 1 minus 2. So I'm going to get -1. And then I'm going to get c. Well, c is 2. And then I'm going to get -1 squared. I'm sorry, I'm going to get 1 squared, which is going to give me 1. Okay. So now I have 5 is equal to -a plus 3. So a is -2. And now I have all of my variables. So when you have a repeated root, you will run out of roots to use. You will choose any number you want. Okay, I suggest you choose something small. All righty, so now we know everything. So let's go back. Okay, so a, -2, b, -1, c, 2. So my original problem so this is going to be the integral of -2 times 1 over x minus 1 over x squared plus 2 times 1 over x minus 2 dx. So I'm going to get -2 times the natural log of the absolute value of x. When I integrate -1 over x squared, that's integrating -x to the -2. That's going to give me a positive 1 over x. And then I'm going to get plus 2 times the natural log of x minus 2 plus a constant. So therefore, in finished form, this is -2 times the natural log of the absolute value of x plus 1 over x plus 2 times the natural log of the absolute value of x minus 2 plus a constant. And we are done. Yet another problem. Sense of accomplishment. Okay. All right, so this last problem we're going to set up. This is the last thing we're going to get to before break. And so we will just set it up because we don't have time to complete it. But it is also a repeated root problem. Okay, so as you can see, we're going to have x cubed minus 2x plus 1 . over x times x minus 1 cubed. Now notice this factor appears 3 times. So that's going to be a over x for the first one, but I'm going to have b over x minus 1 plus c over x minus 1 squared plus d over x minus 1 cubed. Okay. All right, so our roots are x equals 0 and 1. Here's the major equation. It's going to be x cubed minus 2x plus 1 is going to be a times x minus 1 cubed plus b x times x minus 1 squared plus c x times x minus 1 plus d x. Okay. You can let x equal 0, let x equal 1, and then you need to choose 2 x's. Okay, and we'll see what you got when we come back from break. Any questions?
I'm sorry, Dr. Lott. I didn't hear when the test was again, but you said you were gonna post it on the Blackboard announcement again?
I certainly am.